Final example 3. You won't get anything this ugly in your homework. I just want to throw one extra one up here. It's uglier because there's more terms. It's actually not quite as bad as the last one because there's only one binomial instead of two binomials, so all this foiling's not going to happen this time. So that's nice. But the more terms there are, the more multiplications you have to do. So, and also this one has some non-fractions in it, so I want to deal with that. Main fraction bar is always the longest one. It's easier to find in these than it was initially. Initially it was like almost the same size on these problems, so it was hard to tell. But the long one's always the main fraction bar in these cases. So if I write 2 over x squared plus 5 over x plus y plus 7. I'm leaving a little bit of space between these again with the intention of multiplying everything. I'm going to put everything in parentheses, so even the 7 is not a fraction, but I'm going to put it in parentheses anyway. On the bottom, we've got a 3. We've got a minus 2 over y. Wow, that's bad writing. Try again. And then plus 4 over x squared y. So again, the first step is what it is every time. Write everything out, parentheses around every single object in the problem. The least common denominator is made up of all the types of denominator pieces. We have x's, we have y's, and we have x plus y's. Again, x plus y does not match x or y, it's its own object. X plus y is to the first, x is to the second and second. Always take the highest one. Y is to the first, highest one. So x squared y, x plus y is the least common denominator of this whole thing. So that's what I need to multiply every term by. Again, there's 6 terms, so I've got to do 6 multiplications. So I'm going to multiply this times x squared y times x plus y. This times x squared y times x plus y. This times x squared y times x plus y. This times x squared y times x plus y. This times x squared y times x plus y. And this one times x squared y times x plus y. So again, there's 6 terms in the original problem, so I'm going to have 6 multiplications of the least common denominator to fix it. In essence, what I'm doing here is I'm multiplying top and bottom by the same thing, and I'm distributing what I'm multiplying through. So I find it better to write it out individually like this rather than write it over here and distribute. That way you can start striking things out and crossing things off and stuff like that. So every least common denominator represents a whole number structure being multiplied by a fraction structure or a whole number structure. So keep that in mind. These are all top objects. These 4 things have bottom objects, these 2 don't. So there's no cancellation happening on these 2, only on the 4 fractions will cancellation happen. This x squared cancels that x squared, leaving me with 2 and y and x plus y. This x plus y cancels that x plus y, leaving me with plus 5x squared y. Nothing cancels here, so I'm left with plus 7x squared y times x plus y. Nothing cancels here, so I'm left with 3x squared y times x plus y. Again, 3 is a single object, x squared y is a single object. Put all the single object stuff in front. Don't give me x squared y, x plus y, 3. It's not wrong, it's just a little uglier and harder to deal with. So put all your single object stuff in front. This y cancels that y, so I'm left with minus 2x squared times x plus y. And that x squared y cancels that x squared y, leaving me with plus 4 times x plus y. And again, that is in parentheses form still, so now my next step would be to distribute. The only careful distribution I have to do is right here. That's a negative 2x squared, distributing a negative. The sign goes with it. So I end up with, if I distribute here, I'm going to get 2xy plus 2y squared plus 5x squared y plus 7x cubed y plus 7x squared y squared. If I real quick look at those, do we see any like terms? A couple of close ones, right? X squared, y, not quite. Xy, x squared, y, not quite. X cubed, y, x squared, y, not quite. So there's no like terms. So the top is done. The bottom, we get 3x cubed y plus 3x squared y squared minus 2x cubed minus 8x squared. And again, be careful, that's a minus because that negative is distributing with the 2.
Why is it 8?
2 times 4. Oh, is that a y? Sorry. My y looked like a 4. It's because I had bad handwriting. Fix that. This is a y. All right. So negative 2x squared times y makes negative 2x squared y. There we go. And then we get plus 4x and plus 4y. And once again, doing a quick look for like terms, I don't see any. All right, so there's no like terms on top or bottom. Possibility of cancellation exists in these, but x is in every term except for that one, so x doesn't work. And y is in every term on top, every term on bottom except for that one, so y doesn't cancel either. So no cancellation exists. That is the answer to that problem. Again, your homework problems won't look like that. But it's a good practice to have gone through it and see it again. And every skill I went through from here to here is just basic distributive property. And from here to here, multiplication by common denominator, get rid of fractions. So skills we've done before, you're just being encompassed into this problem.